what is a limit? The limit is a value that if we have a function, the value that that function approaches, so the value that that function approaches as the inputs also approaches a particular value. So the mathematical expression for this is this, that the limits of this f of x, our function, as this inputs, this x, our input here, as this x, the input, approaches a particular value a. So what does this function approaches? That is L. Then we see L is the limit of this function as x approaches L. So let's look at an example. So in this example, we have the limit of x, this function x squared plus 4, as x approaches 2. So here we can see our function f of x is x squared plus 4. So now we look at the values that approaches 2. So we say our value input x is approaching 2. So let's draw a number line. Say this is 2 here. So we know here we'll have 3, here we'll have 1. So the values that are approaching 2, so maybe we can start with here 2.5, and the values here are approaching 2. Maybe here we'll have 2.01. This is approaching 2. Here we'll have 2.001. So all these are approaching 2. Here maybe we'll have 2.001. So maybe, sorry, 3 zeros, 1. All these values are values that are approaching 2. And these are the values that are approaching 2 from the right. Let's see those that are approaching 2 from the left. So maybe we can say maybe here we have some value, maybe 1.999. Maybe here we have a 1.99. Maybe here we have 1.9. So all these values, so we have the values that are approaching to can be either from the right or from the left. So to make sure that this is a limit, we have to check each of these values. So let's let me just write a table. So let me call this left hand limit, and this is maybe RH, right hand limit, RHL. So we know our function is x squared plus 4. Here is also x squared. We are having the same function. So let's start with the left hand. So let's start with this one, 1.9. Then we'll be approaching 2 and see. So at 1.9, then in this our function x squared plus 4, instead of this x, we remove it and substitute with 1.9. So instead of this x, I'll have 1.9 square plus 4. And if we calculate this, we'll have 1.9 times 1.9, 1.9 times 1.9 plus 4. This will give us 7.61. Then the next is 1.99. We substitute 1.99 square plus 4. So if we multiply it also, 1.99 times 1.99 plus 4, this will give us 7.96. So approximately, then the next is 1.99939 times 1.999, then plus 4. Then here we'll have also 1.999 square plus 4. This will give us 7.99. 7.996, and this is if we approximate this will definitely be it. Let's take the right hand side limit and see. At the right hand side, if we start with 2.01, then we'll be approaching 2. So 2.01, instead of this x, then we put the square plus 4. So we'll have a 2.01 square. Then this will be 4.04. Then the next we'll continue approaching the 2.001 square plus 4, and this will be so this will be 4 point, sorry, this is 8, sorry, not 4, 8. So this is 8.004, and the next is we continue approaching it, 2.0001 square plus 4, and this will be 2.0001 times 2.0001 plus 4. So this will be 8.0004. And you can see this is approximately equal to 8. So we can see from both the side, the left and the right hand side, this function approaches 8. So we say that the limit of this function is 8. So the limit of x tends to 2 of x squared plus 4, this is 8. So our limit is 8. And another alternative method is to just say x2. Instead of this x, we just substitute 2. So we'll have, instead of this x2 square plus 4. So then this will just be, so let me just write it. So limit of x squared plus 4, we can just say this is equal to, instead of this x, I substitute 2 square plus 4. Instead of this x, then this will be 4 plus 4. So this is 8. So when does a limit exist? A limit exists if the function approaches the same value from both sides of the input. Like in our previous example, it approaches the same value from the left hand side and from the right hand side. For instance, this is a plot of a function x squared, f of x is equal to x squared minus 5. Like, let's look at this function, the limit of x approaches 3 of this f of x. If you look at x approaches, this is our 3 here, this is our 3 here. Look at when x approaches it from the left, it kind of approaches 4, and also from the right, that is from here and from here. You can see from both sides, it's kind of approaching 3. So we can see that the limit exists, and this limit we can just write it as instead of this x, we substituted with 3, that is 3 squared minus 5, and this is 9 minus 5, which is 4. And when limit does not exist, so limit may not exist in case of oscillation or discontinuities, or if the limit of the left hand side is not the same as the limit of the right hand side. Like here, there's a discontinuity because from this, if you look at this plot, is f of x equal to x plus 2 when x is greater than 0, x minus 2, x is less than or equal to. You can see from this point, the line starts from this point. When it reaches here, then it jump. So this jump shows that there is discontinuity. So therefore, the limit here does not exist. So so that's why in this example, if you let's look at the limit from the left hand side. At x, maybe limit at x approaches 0. So if you look at the limit of this function as x approaches 0, look at this. At x approaches 0 from the left hand side, the limit is minus 2. But when we approaches it from the right hand side, x approaches 0, the limit here is 2. From the right hand side, we have 2. So we said here the limits do not exist.